Welcome to microprocessor tutorial. Today I'm going to explain 8085 microprocessor architecture. In architecture, we will see internal design of the processor. If we understand the architecture in clearly, then it will be very helpful in understanding the complete course. That's why it is very important to understand the microprocessor architecture. Now, first I will explain in briefly what are the components in the 8085 microprocessor? First, registers. Already I explained you about the register. Please go through my introductory lecture. In that lecture, I explained what is the purpose of register. Now briefly, registers are the storing elements which stores operands, instructions, address. So now registers can be divided in two categories: general purpose registers, special purpose register. General purpose registers means these registers are directly available for the programmer. These registers can be used as per the requirement. And special purpose registers, here the purpose of these registers are fixed. Suppose if we take program counter, the purpose of the program counter is store the address of the next instruction. So it is only used for storing the address of the next instruction. Here you cannot store the operands. Your purpose is fixed, so that these registers are called special purpose registers. You know, the size of these registers, here you can see all general purpose register size is 8-bit. Because this 8085 microprocessor is 8-bit processor. That means it will take 8-bit data at a time and process 8-bit data and release 8-bit data. So that's why it is 8-bit processor. As the processor is 8-bit, so all registers having the capability to store the 8-bit. If the processor is 16-bit processor, then all the registers has to be 16-bit. Here you can see that program counter and stack pointer are 16-bit register. Why these two are 16-bit register, I will explain it in detail later. Now onwards, so here I am introducing just what are the components here. Now here you can see general purpose register, here accumulator, register B, C, D, E, H, L. These are general purpose register. Now coming to the special purpose registers: program counter, stack pointer, instruction register, flag register, temporary register, register W, register Z. Now see where these registers are. Special stack pointer is here, program counter, instruction register, IR means instruction register, flag register, temporary register, and register W and register Z. So these are the special purpose register. After that, bus system. Bus means what? Just connecting wire. So it is very important, because whenever you want to transfer data from one point to other, it must be required. Without connecting wire, how can we transfer data? So here buses can be divided in three types. Address bus, so these buses to transfer the address. Next, data bus, here data will come to the processor and data will go from the processor to memory. Now control, third one is control bus. These buses are used to send a control signals from timing and control. So next, so bus system, we can see here these are all buses. We can see in internal architecture. These are all buses. So now next, in instruction decoder. So instruction decoder is here, instruction decoder here, and timing and control unit, and this one is here, timing and control unit, arithmetic and logic unit. This one is here, arithmetic. This is the ALU. It performs the arithmetical and logical operation. So now the interrupt control and serial control, these two are here, interrupt control and serial control. Now in the next lecture I will explain in detail the functionality of each and every component in the 8085 architecture.